All right. Good morning, good afternoon, good evening, whenever you may be. Guess what? It's another exciting adventure into science here, live from the Brenna bunker, somewhere in the quarantined, windy, and soon to be free Southeast United States. Got the protection on today just because we're going to talk about severe storms down here in the bunker, just to make sure we don't have damage ourselves. So, hope everybody's staying safe again. And like I said, on Friday, we're supposed to get things kind of opened up back here a little bit here in North Carolina. So I'm hoping that everybody maintains their social distancing, even if they go out on Friday and start visiting some of these stores. They're going to open back up. But that's then. This is now. We got a couple more days till that happens. Once again, make sure you like the video. Make sure you subscribe to the channel. And remember to put, throw a hi down there in the comment section saying, hey, we're here today in class. So I know some of you guys are like, hey, there's not that many people to do that. Well, that's the case. And so there may end up being consequences for the folks that never show up, but we'll see. But do make sure once you watch the video that you throw a hey down there in the comment section to tell me you were here. Once again, and if you do have any questions or anything else relating to this or anything else that I assigned, make sure you get, you can always call me, 704-363-9034, text me, drop me an email at the school email address. I'll respond. If you don't get anything back from me within, 6 to 8 hours, do it again, please. With spam and crazy phone calls and life in general, things do get slipped by. But again, you'll hear back in a short period of time. Try it again. All right, so today we're talking about, again, 7.E.1.3 Earth systems. We're still talking about severe storms. Yesterday we talked about thunderstorms and tornadoes. Today we're going to talk about hurricanes. So I can describe different types of severe storms. Yesterday we talked about thunderstorms and tornadoes. We're going to look at another windstorm. It's on a much larger scale, the hurricane. Now we've heard about them, right? Well, did you know the same type of storm in the Pacific is either called a cyclone or a typhoon? So, well, just in case you ever hear those two terms, I mean, we're all talking about the same type of storm. It's still a cyclonic, low pressure, warm water fed storm, out of the ocean or making landfall. It just depends on where in the world you are. If you're in Asia or China or Japan, you call it a typhoon. If you're in Australia, you call it a cyclone. If you're in the United States, you call it a hurricane. So that's just how those things go. But to start off with, hurricanes are usually formed over very warm water and usually during a specific period each year. Here we call it the Atlantic hurricane season. It runs from June 1st to November 30th every year. In the different parts of the world, it runs a little bit different, time-wise a little bit differently depending on where you are. But for us here in the US, it's June 1 to November 30th. Now, guess what? Is that hard set in concrete? Absolutely not. Just like anything else dealing with nature, there are occasions when things are, happen outside of what we call the hurricane season. But it's rare. But again, there are no hard and fast, absolutes, especially when you're dealing with Mother Nature. This period is when the conditions are most favorable for tropical development. It's referred to as tropical because the region of the planet where these storms develop is the area surrounding the equator, which is the Tropic of Cancer north of the equator, and the Tropic of Capricorn south of the equator. In this area lies the ITCZ, or Intertropical Convergence Zone. All right, for all you weather geeks out there, of course, it may just be me, but ITCZ is the area that one can see from space in this photo. So we look at this photo right here, and you see this line of storms right here, stretching west off the coast of Central America, and you see it, going that way too. It runs like right there. That's the Intertropical Convergence Zone. So it's just north of the equator. Because at the equator, there's kind of a nothing. But just north of the equator is the Intertropical Convergence Zone for the northern hemisphere. There's one for the southern hemisphere as well, But right here, where this satellite photo is taken, you don't get a whole lot of storms. You'll see down here in a second. So this is in the sailing days. This area right here was known as the Doldrums, and if you sailed into it and were unlucky, the wind might die down, and you could be calm for days or weeks, which means you basically, your ship doesn't move, and you could literally starve if you're becalmed long enough because you run out of food and water. But it's this lack of wind, organized wind, that makes the ITCZ the birthplace of tropical storms. So here's the follow-up here. Every storm track from 1985 to 2005. If we look at this thing and you're like, over here is the United States. I'm gonna blow this thing up right now just for sake of looking at it while we're sitting here. But I'll shrink it back down for the document. So over here, you notice here's the intertropical convergence zone for the north. Runs right through there, and guess what? It's where most of these storms originate. Here's the southern intertropical convergence zone. Over here, notice there are very few storms. There's a couple of tracks right there, but that's it over here in the southern Atlantic. Over here in the southern Pacific, around Australia, yep, plenty of storms over there. So the ITCZ occurs in both, the northern hemisphere and the southern hemisphere. Just over here, the northern hemisphere just happens to be more active. And you notice all these storms starting right through here. So they come up, swing up in the States, and then wander back out that way, depending on what's going on. They all start seemingly right in here off the coast, the west coast of Africa. And then we have a whole other one. But again, look how many more storms form in here than over here. There's so many here that these little bitty lines have basically, colored in that area. All right, and I just noticed this, but look at this one line right here. It goes up here, swings up this way, turns this way, comes all the way back, and then turns south and goes back this way. Guess what? And that's like one line. Weather is a fickle thing. Strange things happen. I'd be interested to see which storm that was at some point, but that's a topic for a later date. So let's shrink this back down. So you can see where the actual equatorial area is free of tropical development. That's this blank space in here. That's literally the equator. The area is immediately north and south, where nearly all storms originate. Tropical cyclogenesis, wow, there's a fancy word for forming storms, requires 6 main factors: sufficiently warm sea surface temperatures, at least 26.5 degrees Celsius or 79.7 degrees Fahrenheit, basically 80 degrees. Atmospheric instability, which means there's a lot of energy, but not a lot of organization. High humidity in the lower to middle levels of the troposphere. Excuse me, enough Coriolis Force. Hey, there's that word Coriolis Force again. Coriolis Force, remember, it's you have a rotating planet as it spins. That just the energy of the planet spinning creates a force vector that happens to act on things that are moving. That's what causes things to spin. It's why when you flush the toilet, it circles one way in the northern hemisphere and circles another way in the southern hemisphere. So enough Coriolis force to develop a low pressure center, a pre-existing low level focus or disturbance, and low vertical wind shear. The doldrums supply the instability and low vertical wind shear. Wind shear is simply a change in wind speed or direction over short distance, and vertical is just up and down. So when you talk about wind shear, it's just you're walking, if you're walking right here and the wind's blowing from your right side to your left side, and then you walk, 100 yards down the road and suddenly the wind's blowing from the other direction, that's wind shear, the 2 different directions of the wind in a very short distance. So hurricanes start as an area of low pressure that comes off the west coast of Africa. Again, go back to right here, our little thing right here. Look, there's the west coast of Africa. So we have what they call them tropical waves. So it enters the intertropical convergence zone. Depending on the conditions there, can form a simple group of thunderstorms or a tropical system. So once a tropical system is formed, it kind of takes on a life of its own. The heat of the sun, warmed ocean provides its energy. The rotation of the earth provides Coriolis force, and the low pressure system starts to build itself into a hurricane. Tropical cyclones have stages of development. Weather forecasters will talk about tropical waves coming off the west coast of Africa again. West coast of Africa, right there. waves coming that way off the west coast of Africa, entering that warm water over the Atlantic Ocean. And some of these waves will gain some organization, then referred to as a tropical disturbance. So tropical disturbance has some organization to it, has some wind speed. It's upwards of 20 miles an hour on average. So it's starting to get a little bit of a grip. If the storm continues to build, it becomes a tropical depression. At this point, it's given a number referred to as TD, and whatever the number is, TD1, TD7, TD14. You'll get a bunch of tropical depressions over the course of a hurricane season, and not all of them do anything else, besides just form a bunch of thunderstorms. Not all, at the tropical depression level, there is some cyclonic rotation, cyclone, and sustained winds are in the 30-mile-per-hour range. If the storm continues to find the proper conditions for development, primarily warm water and no upper atmosphere wind shear, the storm will develop into a tropical storm. Once it hits tropical storm level, which basically sustained winds in the 40 to 73 mile an hour range, it gets a name. It will start to form an eye and look like this from space. So here's a tropical storm. You can see the rotation of it. Here's a big wind band. Here's a big band. And you're starting to see right there in the middle what could be an eye starting to form here. And look where this one is, right there. Here's North Carolina, South Carolina, Florida. This one was right off the coast of North Carolina. That's a tropical storm. Like I said, winds less than 73 miles an hour. Definitely got some good formation going on there, but not quite an absolute hurricane yet. But if it continues to intensify and grow, it surpasses the 74-mile-per-hour mark for sustained winds, it becomes a hurricane. Hurricanes have levels named by the scientists. Of course, guess what? You create something, you get to name it. And they use, of course, their own last names. The Saffir-Simpson scale breaks down hurricanes into categories 1 through 5, with 5 being the most intense. So it starts at 1, 5 is basically 155-mile-an-hour winds or greater. So, once you hit 5, I mean, that is a, major, hurricane. Katrina was a 5. Let's see. There was one that went across Florida. Matthew was a 5. There's been a couple of 5s that have landed and caused massive destruction in the United States. And of course, obviously, other places as well. But we don't get 5s that often, maybe 1 or 2 a year, and only, they rarely make landfall as 5s. But when you get to that point, I mean, they are very well developed. You can see huge, they call these the, bands, very well formed storm. And look at the eye right there in the middle. Huge eye, very well, very easily seen. So hurricanes are immense storms. I mean, they can be 100 miles across. Bands of destructive wind and rain stretching over, again, over 100 miles. When they hit land, they bring very destructive wind, torrential flood causing rain, and high waves and ocean storm surges. They're some of the most destructive natural disasters we have to suffer through on a regular basis as humans. So again, as this thing's rotating in this direction, what color I got here? We got red. It's going this way, right? Boom. So as the wind blows and it pushes water around, and so as the eye moves, I mean, this thing is traveling. Who knows which direction it's traveling, but it's going this way. So if it's going that way, and this rotation here, always the strongest wind is in this quarter here, the upper, the northwest quadrant is what they call it. That's where the strongest winds are. Again, due to Coriolis Force and all that. But as it hits the water, that's as it pushes this water this way. So it sucks water from this way. So if it hits land, if you're on this side of the eye, the wind is pushing the water away from shore. So actually the water will go out. You'll have an extremely low tide. But as it wraps around, all the wind is blowing in this way on this side. So as the eye runs into the shore, all this wind over here in the strongest quarter of it is pushing the water onshore. And that's where we get the thing called storm surge. Type that out here. Storm surge, it's water being pushed on shore. So it's pushed. So storm surge is water being pushed on shore. So storm surge is one of the more deadly things about a hurricane, especially if you're at the coast. I mean, you don't have a lot of elevation in your land levels there. So if the storm surge is, it acts like a very high tide. But I mean, when you say very high, you could be 8, 10, 12, 15 feet higher than normal. Well, a lot of times the little islands that are on the outside of the coast of the United States, I mean, their maximum height is 10 feet above sea level. So if you have a 10 or 12 or 15-foot storm surge, there's going to be 4 feet of water across the entire island. That's why when you go down some of the beach places, you see all the houses are built on stilts, on poles. When the only thing underneath them, maybe a garage area or something where you park your cars, all the rest of the house is jacked up. So when that storm surge comes across, hopefully the rest of their house stays out of the water. Now, if there's enough storm surge to have 5 feet of water 10 feet above the sea level, I'd be worried more about the wind of that third story way up there sticking up in that wind than anything else personally, hence the helmet, but for flying debris and that kind of stuff. So hurricanes are, like I said, are amazingly destructive storms. We've only had brush in Charlotte here with a couple. Hugo literally was like the 2 years before I moved here. 1988 or 89, no, excuse me, 90, I moved here in 96, 94, 95, 96, somewhere in there. Hugo made it all the way to Charlotte with containing, hurricane force winds, and the trees were down. And when I moved here a couple years later, there were still down trees everywhere. I mean, they hadn't finished cleaning up yet years later. I remember being in Florida, and when I got to Florida, there were still piles of stuff everywhere. And I was like, all these piles of stuff, and they're like, oh, that was hurricane whatever that went through a year ago, and there were there's just Florida, there was no place to so they basically built mountains or park what they're now parks out of all the debris that they had to clear out of different areas, and just cover just all the houses that were crashed and everything else, all this debris they just dumped in these made hills out of, and then covered it with dirt and made a park out of it. But I mean, those hills weren't naturally occurring. That's all the debris from the hurricane cleanup. I mean, so these things are incredibly destructive. But the flip side is, guess what? As humans, we're going, we still like the beach, so we're just going to build our houses, and they, we use science to figure out how to build things to try to resist the forces of hurricanes in a normal hurricane. Well, Cat 5 comes along, and all bets are off. But that's life of living at the beach. Anyway. So hurricanes are incredibly intense, rotating storms, bringing high winds, which they'll blow down the trees, rip the roofs off, flooding from the rain, flooding from the storm surge, and very dangerous. And it's kind of hard to believe that some people will sit there and go, "Hey, we're gonna have a party. We're gonna have a hurricane party and stay and watch what happens." Well, sometimes it's just interesting. Sometimes you don't hear from those people ever again. So. You have to be wary of the power of Mother Nature for sure. But it is something we have to live through. So even especially here in North Carolina, we do get our share of weather from hurricane and tropical systems every year. Anyway, so hurricanes. Hope amazing storms. Just on the physics of it and the weather nature of it, but scary because of the damage and stuff that they can cause. Anyway, so if you have any questions about today or anything else, please once again, give me a call, hit me up on a text, 704-363-9034. But again, like the video, leave a comment in the comment section saying, hey, I was here, and we'll talk to you guys tomorrow. Have a great day.